That's the first part, and this is for part D. This is for parts A through C. We're going to figure out on this problem how many grams of oxygen were used. This time, we're going to say we know that we used 10.0 grams of sulfur. We want to know how much oxygen did that sulfur use up. So we're going to go from grams of sulfur to moles of sulfur, and then we're going to go from moles of sulfur to moles of oxygen, because we want to know how much it used. And then we're going to go from moles of oxygen to grams of oxygen. So again, just say it again. So we've got grams of sulfur. This is the limiting, so it was all used up. So we want to see how much oxygen it used as it was being used up. So this is our 32.07 in 1 mole. This is from the reaction. Look at the reaction there. 2 sulfurs to 3 oxygen. And then in 1 mole of oxygen, I've got 32.00 grams. I've got 3 sig figs, so that gives me 15.0 grams of oxygen. And I always go ahead and write this word in so I've not lost. So are they asking me how much was used? No. They're asking how much was left over. This step always requires a little extra subtraction. I know how much I had. I had this much. This is how much I had. Now I know how much I used, so I just subtract. And it's 32.0 minus 15.0 gives me, I could totally do this in my head, 17.0 grams of oxygen left over. The reason this matters is that if you're using something that wasn't oxygen, something else, then that was really expensive, then you would definitely want to be able to collect and know how much was left over. Or in the case of oxygen, you want to know, probably you'd convert that into pressure to make sure that your vessel can handle the amount of pressure for the oxygen that was left over. That kind of thing. This is very typical for these problems. You should expect 3 sets of train tracks. You should accept a pair that go to the same thing, and then one that takes one of the amounts and turns it into something else. So now you want to work these 2 problems on your own, and I will post myself working these problems after this video. Last bit of information here that you need to be able to do is percent yield, and percent yield is actual over theoretical. So we've been talking all along about theoretical. This is like the perfect, this is the perfect amount. This is as if everything were perfect, this is the number that you calculate. Like with your calculator and what we were just doing. All those numbers were our theoretical yield. And then actual, this is like what you weigh in the lab on a scale. That's the actual. So this is the way that scientists measure not just how well a reaction works, but if it's financially and reasonably feasible to conduct the reaction on a large scale. Also note that your grades are out of a percent out of 100. The 100 would be like the bottom. That's like the perfect amount. Your grade is the actual amount out of 100 points. This is the exact same problem that we just worked in the notes. So we already know the theoretical yield. We have some new information. Now we know what the student measured. When we calculated it, we figured out that it theoretically produced 25 grams of sulfur trioxide. Remember, we did the math, the train tracks. We got 25 grams of sulfur. So we're going to use this equation up here. And it's a really nice, easy equation to end with on this topic. So you're going to take your 1.00 grams of sulfur. That's what was actually produced. Like you'd have to have something that says like someone put it on a scale or in the lab, the student, got this, something like that. That kind of phrasing. That'll tell you that the top number is actual and that the bottom number is what it should have been. So you do that one, and notice this student did not get a very good grade. Maybe they spilled it all over the place or something. You do the math for that, and you 4.00% for part A. Now if we're doing part B, this gives us 24.0 grams of SO3 divided by 25.00 grams of SO3 times the 100%. And we do 24 divided by 25. And you get, this should say 96.0%. That was a much better yield. Don't use the 100 part of this equation to try to figure out sig figs. That is considered exact. And the question for people is that if I added on a part C, and if my part C said that I had weighed it and I had gotten that I made 30 grams of SO3. So if I weighed that and I got 30 grams, would my yield be in that case? I'm going to change color so it's more clear. So if I say that I made 30 grams and that the theoretical yield was 25, that's going to give me a yield over 100. Is it possible to make more than you predict that you can make? No. So this is not possible. Probably what happened is that the reaction is still wet and I didn't give it time to dry. So I'm also weighing water in addition to the reactant. So you need to know that if you ever end up with a yield that's over 100, it's not possible. So in general, a good rule of thumb is just that the smaller number is the one that's going to be on top and the bigger number is on bottom. The exception is if they're trying to trick you, which doesn't happen very often, but I just want to point out that if someone ever tells you they get more than what you calculate, it's not a possibility. I've got another example right here for you to practice on your own. And again, I'm going to write out the answers and you can double check it against that answers to make sure that you've got what's going on. We have our learning objectives that you can look through.